You're listening to What Do Scientists Do? A show where I talk to a different guest each episode and they teach us all about their favorite science topic. My name is Jessica, and today I get to talk to Irekanmi, who teaches us all about mechanical engineering. Hello, everybody, and welcome to What Do Scientists Do? And today I'm joined by our very special guest. Could you give us your name and your pronouns, please?
My name is Irekanmi Awoyiga, and my pronouns are he, him.
And Irekanmi, what do you study?
I study mechanical engineering, and I attend the University of Waterloo.
Super cool. I know that's a really big school for engineering in general. What is mechanical engineering?
I think it'd be good to start with what engineering is in general. So, usually we're told that engineering is about solving problems, and that relates to any problem that you can solve with math or physics. And with mechanical engineers, we tend to solve a lot of problems that deal with things that move. So cars, trains, planes. And aside from that, we also do a lot of work with things that involve designing objects to meet certain requirements. So that also relates a lot to objects in daily life. But usually mechanical engineers, they do a whole multitude of things.
Cool. So are you the kinds of people that you might think of as inventors, I guess?
I'd say for sure. There's so many things that you can do as a mechanical engineer, and because of the expertise that mechanical engineers have with design, with analysis of materials, there's a lot of things that you could design and make. So I definitely say we're inventors.
That's pretty cool. So, in order to become someone who gets to work on like planes and trains and all the different things that mechanical engineers do, what do you need to do to get there?
One of the most important parts is having a really strong foundation in math and physics. Those are the basis for what it means to be an engineer, because a lot of the knowledge that you gain from those two subjects really informs the type of work that we do as engineers. So that's the most important part. And then secondary to that is having creativity or the desire or curiosity to create things. I think that's something that a lot of engineers really have, and that's important to being an engineer.
Cool, yeah. So you kind of have to have ideas in order to then use all the math and physics to make something or improve something, right? Do you have an example, or can you think of an example of something in math or physics and how that ends up translating to engineering?
For sure. I think one of the really basic concepts that's important in engineering is the concept of energy. And that is really involved in a lot of different ways, particularly with if we think about things that move, you need to know how fast what you're creating is moving, and that informs what you need to make it with, what types of materials it has to use, and in addition, just understanding how that energy will impact what you create. And so a lot of the time we look at two types of energy. So the first is kinetic energy, and the second is potential. And kinetic energy is the energy that an object has when it moves. So that's the energy that it has while it's in motion. While potential energy is the amount of energy an object has based on its position. I think an example to illustrate this would be if you have a ball and you lift it up in the air, it has a lot of potential energy at that point because you've lifted it up and so you've increased the amount of potential energy it has. And then the moment you drop it, all that potential energy gets changed into kinetic energy. So now it's moving and it's coming back really fast towards the ground. And so that's one of those basic concepts that I think as mechanical engineers is really useful in our work because that helps us create different things and understand how strong something needs to be in order to withstand whatever kinetic energy it has to go through.
Yeah, because if something's moving really fast or if it's rubbing up against other things, then you are going to have to make it so that it can take a bit of a beating, basically, right? Do you have any favorite things that you've ever done, projects you've worked on, or classes you've taken?
Yeah, I actually have a couple of things that I really enjoy about mechanical engineering. The first would be sometimes I think when we use math to create different scenarios or different problems, it's really fascinating how it's able to accurately predict or model the behavior of things in real life. An example of this would be sometimes in calculus, you can actually use calculus to understand the amount of force that something will withstand, or the amount of energy that you need uh, to do something. And those two things are really fascinating because when you get the right answer and you figure out, okay, this is how much energy this needs, or this is how much force this object is going through, it's really cool because the fact that math is able to accurately predict things in real life is really fascinating. And the second thing would be for me, I really enjoy engineering design. That's something that I'm really interested in. And so I actually started a project where I've been trying to design my own water bottle holder using modeling software, which we call CAD, stands for computer aided design. Um, and so doing that and the process of learning how to use those softwares to make something that I can actually use in real life is also really cool because you get to take measurements of things you want to create, and then when you finally make them in the software and it looks just like real life, it's really fulfilling, and uh, it gives you a really it makes you proud.
Yeah, that's really cool. So you're working on designing this water bottle holder right now. Have you gotten to make any physical version of it yet, or did you just are you only at the design point?
Right now, I'm at the design point, so I actually started off by creating a model of my current water bottle. So I finished that a couple of days ago, and I'm currently in the process of designing the actual water bottle part. And so the reason it's actually so complex is because I have a bike that has parts that aren't entirely cylindrical. They're sort of rectangular, but also irregularly shaped. So uh, something I have to do with my design is I have to understand, okay, how do I want to create this water bottle holder so it can attach to my bike, even though the frame isn't cylindrical. So that's the hardest part now that I'm trying to figure out.
So did this start out of you not being able to find a water bottle holder for your bike that like fit it properly?
Yeah, it
That
did.
that's really funny. That's also really cool. That's a really cool example of how you just had a problem and you were like, "Okay, I'm gonna come up with an engineering solution to this by just designing and making a water bottle holder myself." Do you have any plans of how you're gonna make it? Are you gonna 3D print it or
Yeah, so I'm planning to 3D print it. And first, what I'm planning to do is actually make a sketch of the design that I plan to make. And so in engineering, sometimes it's really important to have an idea where your concept or your design was going to start, because that helps you get a really accurate model for what you actually want to make. So first, I'm going to make a pretty detailed sketch of the design that I want to do, and then I'm going to decide on some measurements, and then I'm going to model it. And then with the help of the model that I've created for my actual water bottle, I'm going to sort of play around with it in the software and like put the water bottle into my design virtually and just try and play around with it and see, okay, will this actually work? Before I actually go to 3D print it, because that's expensive. And you don't want to be reprinting a design multiple times. You want to make sure that the first time you at least get close to where you want to be. Then you can make any tweaks you need. And hopefully by then I'll have a functioning water bottle holder.
yeah, so what's it called when you have all those different versions of your design?
That's known, we call it iteration. So it's iterating on a design, and you take the first one, you look at it, what's good about this, what can be improved. You write that down, you think about how to improve it, you change it. And the fascinating thing about it is iteration never stops. You get to a final design or what you see as a final design, but that still doesn't mean that it can't be improved on.
Yeah, I mean, if we still used the first cars that we ever made, and there was no iteration there, we just stopped. That would be wild. We'd be driving cars that go like 5 kilometers an hour.
For
Um,
sure.
so that's one of the big differences, or one of the differences between engineering and I guess what you would think of as the scientific method, right? Is that engineering has all that iteration. You have prototypes and you have um, improvements and improvements and improvements, whereas science is usually finding the answers to a question that you don't have any answers to at all. And then
Yep.
maybe once you get the answers, maybe then you would use those to do some engineering. Yeah, I wanted to mention that because I think it's cool to think about like how we apply science, and engineering is one of the ways that you can do that. How did you end up going into engineering? Is it a hard thing to do? Is it a hard thing to get into?
I'd say it's definitely something that is, I wouldn't call it difficult, but there's a process to it. And I think the first thing that I would say is, if it's a goal that you have, or if it's a dream that you have to do, go for it, because really anything is possible as long as you put your mind to it. I think for me, it started with actually attending summer camps at Supernova, because I actually didn't really know what engineering was about before that point. So learning what engineering is as a field and what people do, when I figured it out that, hey, there's people who can make whatever they want just by thinking about it and trying to come up with a design, that seemed really fascinating to me. And so ever since then, I decided that's what I want to be. That's what I want to do. Aside from that, it's really important in school, particularly, to engage in subjects like math, science, physics, because those are really, like I said before, the foundation for engineering. And so you want to have a really strong uh, knowledge base in those subjects. It doesn't mean that if maybe you're not the best at those, you can't be an engineer. It just means that those subjects, if you can work at them and you can improve, it's definitely possible for you to get into engineering by doing that. And in terms of the process of studying engineering in university, it's not easy for sure. It's a lot of work. There's a lot of assignments. There's deadlines that come up. But I think if you're studying something you really enjoy and you're studying something you have a passion for, even though it might be tough sometimes, all of those things usually you end up appreciating how much it helps you grow and how much you you learn, because you really do learn a lot. And all of those skills that I've been learning over the past couple of months during the semester are what actually helped me start all of the different projects that I want to work on and the different ideas that I have for things that I can create.
Yeah, it sounds like your classes have actually translated to real life or like real things that you want to work on really well, which I know sometimes can be a bit of a struggle in like the early parts of a program when stuff is more general. So it's super cool that you've gotten the chance to actually try things out right from the start. Cool. Well, thank you so much for joining me today, Irekanmi.
No problem. Thank you for having me. I really enjoyed this.
And as always, a big, big thank you to everybody listening. For more science fun, you can check out our past episodes at bit.ly/What Do Scientists Do, or you can find us on Twitter or Instagram at ScientistDoPod. Do you have a question that you'd like answered by one of our experts? Send us an email or a voice recording at whatdoscientistsdo@superstaff.ca, and we might answer your question on the show. Thank you so much for listening, and I'll see you next episode. Bye for now. This show is made by Supernova at Dalhousie University, a network member of Actua. For more information on our summer camps, workshops, and more, visit supernova.dal.ca.